we are going to present our experiment topic, which is the deflection of the beam. I want to introduce my team member first. And first is Nur Atira Atasha, and second is me, Chai Hawaii, and the third is Muhammad Alif Kwayab, and the fourth is Nurin Hana, and the last is the Muhammad Aiman Imran.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Imran. So today I would like to talk about introduction to our experiment. First, we define a beam. A beam is a structural element that resists load placed on the beam axis. Second, a deflection mode is mainly curved and the load applied to the beam causes a reaction force at the beam support reaction. So there are several types of beam. First one is simply supported beam. Next is fixed end beam, and then cantilever beam. We proceed to the definition of deformation of beam. Deformation of beam is represented in such a way that it deviates from its original position. It being measured from its original surface of the beam to the surface of the deformed beam. There are several ways to calculate the deflection of beam. The first one is direct integration, and then Cantigliano theorem, and then Macaulay function. So we proceed to our objective. The first one is to determine the elastic curve. Second one, to investigate the existence of the bending moment developed in beam based on external loading applied. The third one, to calculate the deflection of beam by using a simple theorem, simple algorithm from Macaulay method. The last one is to identify the relationship between load and the deflection of fixed end beam.
And the next is I would like to introduce the apparatus we are using in our experiment. In the first, we are using the steel plate, which is 10 Newton per each. And the second one is our test specimen, which is the steel bar with a long 1 meter. And the second and the third one is our depth gauge. This is help us to deflect, to measure the deflection of our test specimen after apply the load. And the fourth is a hanger whack, and this will hang on our specimen, on center of our specimen, and after that we will apply load on the bottom of it. And the next is the procedure. And first, we will measure the thickness of the of our test specimen, and after that we will measure the width also using the digital vernier clipper. And after that, we will setting the angles into 1 meter. This got something wrong. And after that, we will see that these two lower angles is about 1 meter, and after that we will put our test specimen on it. And because the angles have a big area, and after that we will put our test specimen on it, and it will cover some length of our test specimen. And so we will measure the angles and get the center of it, and we will start from the center as our S0 and as our starting point, and then so on. The 1 meter long of our test specimen will become 95 centimeter. And so after that, after apply the load, we are using this. After that, we will set the depth gauge to 0 first, and then we will apply the load on the hanger whack, and then we are reading the depth gauge of the deflection of the beam, and we will repeat the step which is apply 10 lots again to measure the deflection until 50 Newton.
Assalamualaikum and a very pleasant day. I am Nurin Faihana. So now I will proceed with the data analysis of the experiment. So we proceed first with the material specification. In this experiment, we use a long steel bar with the length of 0.95 meter. The width and height are 32.18 millimeter and also 5.83 millimeter. As for the moment of inertia, we use the formula for rectangular, which is I equals to BD cube over 12, and we obtain 5.3139 times 10 to the power of negative 10 meter to the power of 4. And for the calculations, for the deflection, we use a simple algorithm from the Macaulay method, which is Y max equals to PL cube over 48 EI, and also we calculate the percentage difference. So as you can see, this is the results for our experiment. With that, I thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Natira Tasha binti Ismail, and today I would like to discuss about this experiment. So in this experiment, the graph of deflection against load portrays a straight linear increase for theoretical and not a really straight but linear increase for experimental. So in this experiment, there are sources of error. The first one is the hook of the load and ruler was slightly moving when replacing the load, hence affect the reading of their gauge. And next, a parallax error in this experiment, as the eyes of the observer are not perpendicular with the scale of the gauge, and thus those are the mistakes that causes the inconsistency of the data and percentage difference obtained. That's all from me. Thank you.
Okay, I would like to start for the conclusion for the project. Okay, for this experiment, we can conclude that our objective of the project has been achieved. We are able to learn to draw and identify the maximum point of the elastic curve. To know how much load required for beam to deflect to maximum deflection and range of deflection for steel is determined when load is applied. We obtain the pitch and beam deflection and percentage difference between theoretical and experimental. For the highest, percentage difference is 30.06% at 20 Newton, while the lowest is 3.57% at 10 Newton. The problem we face in this project is specimens are easily deflect when fuel load was applied. Okay, for recommendation, to ensure the result more accurate, the thickness of the specimen need to be higher rather than being used now. This affect the beam deflect. We need more load to make the first deflection. For the second, use specimen that have higher modulus of elasticity than steel. We should need to use specimen that have more shortened diameter that we already use. The effect after we change the length, when 10 Newton is not applied to the beam will not easily deflect.